Electez Design Suite, EDS, is electrical and instrumentation design software. It has three main modules, and this is a demonstration of the Electez module. Electez is a database-centric CAD application which can maximize efficiencies in the production of the drawings and reports required by electrical designers. Electez, today's topic, uses a CAD engine and a database to produce 2D deliverables such as schematics, single line diagrams, wiring diagrams, 2D panel layouts and reports. Instrument Manager uses an SQL database to produce loops, datasheets and reports. And PanelDes Raceway is used to model 3D planned electrical and raceway systems, including cable routing. Electez Design Suite has been in development for 30 plus years and uses multiple languages and standards. Electez has been used by over 15,000 customers in over 50 countries. This slide shows a few of the EDS customers. Electez is built around a flexible philosophy, which includes smart tools, libraries and templates, all used for increasing efficiency and accuracy in electrical design. For flexibility, we can use templates or typicals for any deliverables or any part of a diagram. Your company can choose exactly how your deliverables look. Databases allow an Electez team to use component-based data, enhancing accuracy and management. Electez users don't spend a lot of time typing or correcting repetitive component data. Your team can work concurrently on any Electez project, from upstream resources such as catalog databases to downstream reporting such as point-to-point wire lists. Electez integrates tightly with the other modules of EDS, allowing instant access to database data and 3D modeling, including cable routing. The integration reduces the chances of errors, double handling and rework. Electez CAD tools include large symbol libraries and intelligent insertion, construction and editing tools to help assemble your circuit diagrams. Electez provides propagation of component data between related components, duplication warnings, and easy component family and subcomponent management. All Electez component names are programmable. Electez will also check your component names against a set of rules. Electez has smart tools for editing the drawing data. You can do project-wide searching and replacement on new symbols, component catalog specifications, tag names, and any other text you wish to change. A component-specific database structure allows for fast data entry and efficient correction tools. Needless to say, the automated production of tables, cross-references, wiring diagrams and reports represents excellent productivity gains for most designers. And just one more reminder, all of the libraries provided can be customized to suit your company's chosen policies and standards. I'll now briefly describe the demonstration I'll do today. I'll start off by creating some electrical schematics from within the CAD environment, followed by the production of a PLC I/O card. I will demo the fast data editing tools such as our global editor, and also demonstrate multiple circuit editing tools for speeding up the CAD environment. After creating the schematics, I will focus on downstream productivity and create cross-reference back annotations, use the navigation tools, and then I will create a refreshable CAD-based table. I will then show you the fully automated production of wiring interconnection diagrams, including terminal strips and device wiring. Finally, I will demo the reporting functionality, including a cable schedule, a point-to-point wire list, and a materials report. I will start the demo with a completely empty project. The project allows me to combine many thousand DWG files to be processed or edited together. I'll use eBase to create a new project. I can use any folder and any project name. My folder is called PC and my project is called PC Demo. My project file name and path are displayed at the top left of the dialog box. I can select the working folder for my project. This enables Windows to provide me with a sensible default location whenever I open files. I'll now close eBase and open an Electez session. The first thing I will do in my Electez session is to save my drawing as a recognizable file name. In Electez, I can use any file name. My next drawing startup step is to insert a drawing border and title block. This can be done at any time, however a boundary is convenient during circuit drawing. I'll choose a medium-sized border. The final step in my initial drawing startup is to add the DWG to the eBase project. I will do this with the PRJ button on the left side of the Electez ribbon menu. The first circuit I will draw will be a three-phase bus diagram. On the Circuit Start Options palette, I can choose orientation, connection and the start components in my circuit. I'll choose a vertical start with no connection. Now I can select the next component in my three-phase circuit. I'll choose a Square D circuit breaker and name it CB1. I'll choose its spec from the catalogue. You can filter the parts to make selection easy. My circuit breaker has a family of subcomponents. Subcomponents are physical parts of the relay drawn separately in a schematic. For example, a shunt trip coil. Click the Subcomponents checkbox to see the family of parts. Each specification is detailed. My subcomponent can contain data for over 20 attributes. Press Insert or OK to All to insert the component. To end my bus drawing macro, I can select End or choose a component that naturally ends the circuit, such as a motor. Electez makes it easy to move components around without losing their connections. I'll now insert a set of CTs on my three-phase circuit. This symbol insertion is a simple MTD, also known as a multi-terminal device. I need to choose the symbol I'm interested in. Note, you can easily make your own symbols. The next step for a simple symbol insertion is to drag and drop the symbol onto the bus. If line breaks are required, Electez will do this. I will name the current transformer block CT1 and select a specification from the catalogue. When using the Electez catalogue, you can filter any of the columns to make your search easier. Note, Electez catalogues contain a significant number of columns for component data, like terminal numbers, ratings, and part numbers. I will now create the signal conductor that starts at the CTs and ends on my first protection relay. Electez uses CAD line segments for conductors. I can simply draw my conductor with the line command. Electez symbols are terminated on a grid, making the wires easy to construct and align. I will now use the Terminals menu to insert a junction box terminal on my conductor. As with all Electez components, I give the terminal a name and then choose a spec from the catalogue. Electez has added electrical intelligence to the CAD session. The CAD session will now react to any copying and pasting of a component in a smart manner. When I copy the terminal, the number will be incremented in a circuit-sensible manner. The lines are appropriately broken and connected, and the spec is transferred. I want the second terminal to be in my PNC panel rather than the junction box. I can use basic CAD edit commands for this simple edit. Before I move across the circuit, I will add a cable core between the junction box and the protection control panel. I can simply drag and drop it from the palette menu. As with all Electez components, the cable must be named and specified. I'll name the cable C1 and I will choose a 6-core Belden cable from the Electez catalogue. Cables within Electez are also intelligent and contain routing information such as power segregation, weight, cross-section, fill, and minimum bend radius. The next component I need in my circuit is a test plug. I can insert that from the Protection Control component menu. I will name the plug TP1 and choose a specification from one of the Electez catalogue samples. Electez catalogues are easy to create and also to augment. You can add extra data columns to existing components, and you can add extra components to existing catalogues. I'll now use the Protection Control component menu to insert a CP input block. I can drag the block onto the conductor and then drop it. I'll name my relay R1. I'm going to use a Schweitzer relay from the SEL315 family. This relay is complex and specifically for managing large circuit breakers. Two of the more important facets to manage with protection relays are the arrangement of inputs and outputs, and of course the terminals on the I/O. In the Electez catalogues, the I/O are structured as subcomponents and tracked as you use them. The terminals are properties of each I/O subcomponent. Tracking of the protection relay I/O and terminations is automatic with Electez. To complete my AC circuit, I will copy the first conductor and its componentry to the other inputs on the relay. When I copy the circuit multiple times, the names of all of the components will be adjusted by the Electez circuit reactors. When you have tags that you want on your reports, but don't want to see them on the drawing, the Electez Attribute Visibility tool can be used to hide the tags. I'll now add a few wires to the circuit. Again, these are simple CAD commands. A typical Electez user needs to know approximately 20 or 30 basic CAD commands only. To create the final terminations on the CT block, I will copy the terminal and wires from the first common signal line. I will now create a couple of lines to represent the common side CT jumpers in the junction box. Orthogonal lines tend to be preferred for electrical wiring, however the Electez wiring can be drawn at any angle. I'll use a 45-degree connection indicating that the junction box jumper wires are not part of the cable. At any point where two lines intersect, we can force an electrical junction. Wire connect dot symbols representing a junction should be inserted. Connect dots can be automatically inserted by Electez. I will place wire connect dots on the common side on the relay CT inputs. Most circuits need wire numbers allocated. Electez can automate the wire numbering process. I will start the wire insertion function from the menu and then select the lines on which I wish to add wire numbers and specs. I'll choose a wire spec and set the first wire name to W1. Another method to insert multiple wires in a single operation is by sketching a line across the conductors I wish to name. Then I set the name and spec. And finally I press OK to all. Electez provides a simple dashed box macro for indicating that your components are contained in an enclosure, like the junction box. This completes my AC CT circuit. Most of the time, a designer will not need to create circuits from scratch. This only needs to happen the first time a circuit or a part of a circuit is created. I wish to have CT inputs on both sides of my circuit breaker asset, so I can simply copy my AC circuit. When I copy the circuit, the Electez circuit reactors assist, and the names of all of the components will be incremented. If further adjustment is needed, I could quickly modify component tags and specifications with the Electez Global Editor. I will now zoom out and save my file, then start a new drawing. I will now use another Electez macro. This time I will construct a simple ladder. I can adjust the run count and spacing. As with all Electez macros, the circuit is assembled with line segments for wiring and are smart Electez components. After creating the ladder, I can select and insert components on that ladder. Before I insert devices, I will adjust the rungs to fit some of the larger components and add some extra wires. Another method of symbol insertion is the inserting of subcomponents for devices in the project. When tasked with drawing up a protection control relay with, say, 30 family members and 60 terminals, it pays to be accurate and to manage your contact's terminals. The Electors tool for managing subcomponents is extremely useful when managing protection control relays for larger equipment and higher voltages. I will firstly place the relay's auxiliary power supply onto my ladder. Now I will insert 3 opto inputs from the relay. As the symbols are inserted, they become unavailable for further insertion. This ensures no duplications occur. The terminals and ratings, such as input status or output function, are managed, saving a significant amount of production time and rework. Next, I will insert 2 contact outputs on the ladder. These subcomponents use simple contact symbols. All attributes are loaded automatically from the relay's catalog specification. The CB1 breaker has 3 alarm contact outputs and 2 trip coils that I need to integrate into my protection circuit. These will go on rungs 2 to 6. I'll insert the contacts first. Again, management of the contacts is very important in this design. These contacts will be used to signal the protection relay, indicating a fault, which should trip anything that depends on the breaker. I'll now insert the trip coils from the CB1 breaker to my ladder. Firstly, the shunt trip coil, and then the undervoltage trip coil. I'll now run a cable from the panel wiring to the breaker. Firstly, I will place a terminal on the circuit. I can choose the terminal style from a palette menu and then position the terminal on my ladder. I'll supply a tag name for the terminal strip and supply a terminal number. Electors uses this data to identify the terminal and to group together the terminal strip. Electors provides the next terminal number available and a list of terminals you have used in the project. The terminal is inserted into the wire at the chosen point. I'll now make a copy. Electors assist with the copy by determining the orientation, breaking the lines, and providing the next available terminal name. I'll now insert a cable core marker on each side of the breaker or alarm contact. I can drag and drop the standard Electors symbol and then set the cable name and the core name. I'll choose a 2-core cable from the Belden catalogue. The cable core insertion process automatically repeats after each insert. I'll now copy the terminal and core symbols across the circuit. Electors assist with the copy by determining the orientation, breaking the lines, and providing the next available terminal and cable names. I'll use the stretch command to move my trip coils to the lower end of the ladder rungs. I must now link the alarm contacts to the protection relay inputs. I'll use 5 simple control relays. In a demo, I'm not concerned about the type of relay, so I will select a sample. I'll insert a relay coil at the lower end of rung 2. Then I'll copy it to the other rungs which currently contain output contacts from the protection relay and the breaker. The copy process is again smooth and easy because of the Electors reactors. The next step of the process is to use each control relay's normally open contact to signal a status to the breaker and the protection relay. I'll use the Insert Subcomponent function again to select the normally open contacts from the control relays. With this circuit, I am propagating a status signal from one device to the next. While I'm doing that, I'll discuss some of the Electors simple drawing and drawing edit functions. Electors allows me to easily change the orientation, tag name and the spec of any component or group of components. I can easily move components with line breaking and repair being fully automatic in Electors. I can quickly reverse any component symbol. I can swap a symbol for another symbol by simply dropping the new symbol over the old symbol or by picking a preferred subcomponent from the device. I will now add wire numbers to the sheet. I can select wire extension markers directly from the Elekta symbol menu. I need 4 wire extension markers to extend the circuit. These extension markers can connect a signal to another location on my circuit, including jumping to a different sheet. The first 2 markers connect to the DC supply in my circuit. The other 2 markers feed a fault signal from the second PNC relay to the first. This smart extension symbol can be inserted with a connection at either end and can be oriented horizontally or vertically. The wire extension markers must match wire names at each end of a jump. Elekta has an automated system for inserting wire markers on unnamed wires. When I run the wire marker insert function, I can either place single wire marker symbols on conductor lines one by one, or I can select a window of conductor lines to mark with wire markers. I'll choose a window. Now that the DC circuit for my first protection control relay is completed, I'll save it. Next, I'll use Save As to make a third circuit. For the third circuit, which will be a DC circuit for the second PNC relay, I'll make a slightly simpler version of the circuit used for the first PNC relay. I'll quickly remove a few rungs from the ladder to simplify it, and then I'll use the global editor to correct any duplications I may have created. Global Editor takes a snapshot of the database from my project. It allows me to easily identify and group components, then efficiently rename and respecify those components. For example, I could find all of the wire numbers on a sheet and increase them by 50. I could also find all 10 amp fuses in my project and replace them with 20 amp fuses. Databases add a lot of power to electrical design. Within the Global Editor, the components are segregated by type. There is a table for devices, cables, wires, terminals, and several other table types. The Global Editor can be used to edit components on a section of a drawing, on a whole drawing, or any number of drawings from your project. I'll start the Global Editor and global edit my third sheet in its entirety. I'll ensure I have not duplicated tag names. Firstly, I'll edit the Devices class. Devices include electrical components such as motors and circuit breakers. Devices do not include terminal strips and conductors. I'll now use the increment-decrement function to renumber all of my relay subcomponent tags. Renumbering tags is necessary to avoid duplication. I can also change the specifications of these new circuit devices by using the Select from Catalog tool. I'll select the second contact from the control relays. Next, I'll switch to the wires table. From the wires table, I can increment all of my wires by 20. So for example, V11 becomes V31. This renumbering tool saves a lot of clicking and typing in the CAD environment. To save time, I won't reselect the spec for these wires. Although there's a lot more functionality available in Global Editor, including other classes and other attribute change tools, I've made the necessary changes that avoid tag name duplications. I'll save my changes and exit. The third circuit is now completed, so I'll save it. Elekta can automatically cross-reference your circuits on a project-wide basis. I'll firstly cross-reference the wire extensions. This automatically places a reference to the other end of the wire jump alongside each extension. Cross-referencing captures the position of the components, then assigns them a zone on the diagram. The zone could be a grid square or a rung number rectangle. My referencing tells me the sheet number and a grid square such as G8 or F9. Elekta has a project-wide navigation system. You can simply pick a component and jump to its other references. I'll choose a wire extension and jump to the other end. The navigation tool opens the drawing containing the other reference, zooms in on the component, and then highlights the reference with an arrow. While I'm at the other end of the extensions, I may as well use the cross-reference tool to insert the references on these wire extensions. Cross-referencing of families of subcomponents often requires a table to be positioned and created. I'll insert a table header. A table header needs to be linked to a component with a family that needs referencing. I'll make a table for the relays K4 and K5. I'll position the headers in the space under my relays. I'll select the cross-referencing tool from the ribbon menu. The cross-reference tool asks me which components and tables I wish to reference. Zooming in on the complete cross-reference tables, I can see that the relay family is tabled and referenced project-wide, including terminal numbers and spares. 2 points to quickly mention. The cross-referencing tool is open for customization, so for example you can use your own symbols. And secondly, the visibility of any reference is easy to control. I'll now show you some more from the Electez navigation tool. If I select a strip terminal, then Electez will offer me a list of all terminals in that strip. This list allows me to easily navigate to any part of the strip. Similarly, Electez can track and take me to the location of all subcomponents from my protection control relays. Subcomponents are often spread over multiple sheets. In this instance, I will navigate to the CT input block on the AC diagram for my protection circuit. All drawings that are included in the Electez project will be included in cross-referencing and navigation. Navigation is not restricted to components on your current drawing. For example, you can enter wildcards in a search. I'll search for any items with a tag name of W star. The asterisk is a wildcard meaning any text. If you don't type any search text, the tool will list all components and conductors, then choose any component to navigate to it. I'll navigate to one of the test plugs. I'll now set up a fourth sheet and demonstrate the Electez PLC card generator tool. In the first step, I will choose to edit a card file that I've already configured. I must pick the file containing the card configuration. In the first page of configuration, I can choose the card tag name, panel number, and its first address. I must select a card type from the catalogue. Finalising the addresses and I/O descriptions can also be done from the first page. I'll type a few demo descriptions in. Electez supplies many manufacturers and card types in the catalogue. You can easily add your own. I can also choose the I/O circuit macro for each I/O. This can be one of the sample supplied macros, or you can make up your own I/O circuit macro. On page 2, if you've chosen I/O circuits that contain wires, cables, terminals or devices, then the PLC tool will request the first tag names and the specs for those components. To save time, I won't change these values. When page 1 and page 2 have both been completed, we can save the PLC card configuration file. You can make up as many card configuration files as you wish and draw them later. I'll now run the PLC tool again, however this time I'll select the option to draw a card. I need to decide the orientation of the card, which I/Os to draw, and the side of the card on which I will attach the I/O. I'll make the card vertical, left side, and split my 16-channel card after channel 8. I'll position the second part of the card on the right side of the sheet. After I've drawn all of the parts of this card, I can cancel out of the PLC tool. Note, the card is still templated in the configuration file, so I can rebuild it at any time. Let's now examine the card I've created. The card has multiple wiring macros in use on the two parts. The I/O addresses, descriptions and card terminals are all set, and the wiring, terminals and field devices are all tagged accordingly. Just a quick note. The Electez PLC tool can be customized to suit your needs. You can add card types, manufacturers, I/O circuits, and of course you can substitute your own symbols, colors, layers and graphics. For the next part of the demo, I'll create a wiring diagram, a great tool for wiring your panels, devices and terminal strips. Wiring diagrams give you a list of all of the relevant wires to terminate, plus the terminals to connect them to, and a diagrammatic position for each terminal. The tool displays a list of all of the devices and terminal strips in the project. I can filter by enclosure if I wish. I need to select the checkboxes alongside the devices I wish to draw. I'll select the terminal strips, the PNC relays, and a couple of the control relays. The front page of the wiring diagram generator has quite a few layout preferences that you can alter, such as orientation, mirroring, and selection of templates. After I select the Create button, Electez will ask me to position each device. I'll place the control relays on the left, protection control relays on the right, and the terminal strips below. It's a common strategy to lay out the devices so they mimic the panel's rear view or wiring view. The wiring diagram generator has many custom settings in the preference pages. You can create a diagram exactly as your standards require. The Schweitzer PNC relay is extremely complex. Having a single explicit diagram to define its wiring is a big efficiency gain when compared with wiring from 20 schematics. You'll note that the terminal strip contains all of the cabling, wiring and jumpers. This diagram was assembled from many sheets of schematics. Historically, a manual wiring diagram takes about the same time to collate and draw as a schematic, hours or even days. If a revision occurs, the wiring diagram rework will take a similar amount of extra time. Errors often occur when manually synchronizing wiring diagrams and schematics. Navigation is possible between project wiring diagrams and project schematics. Electez wiring diagrams are fully automatic, sync error free, and take seconds to create, not hours. They are 100% refreshable, so revisions cost nothing. Companies using Electez get all of the benefits of wiring diagrams without the costs or lost time. For the next part of the demo, I will create a live materials table. This tool is used to transfer materials information to CAD in a tabular form. The first step involves selecting the data file which contains the material data. I need to select the columns that are to be displayed, such as tag name, part number, and panel number. Now I need to set the table spacing and format. Firstly, I will set the format to include border lines on all columns and also on the title row. I know that the catalogue description and reference columns are longer than the default, so I'll make them larger. If a column overflows the spacing, the text will automatically wrap. I will adjust the text height for all table text. I can limit the rows allowed on this sheet by including a panel filter or by fixing the first and last rows. I will now press OK and position my materials table on the sheet. The materials table is now drawn. The table is both adjustable and refreshable. By adjustable, I mean that I can edit the table at any time and adjust the contents, format and layout of the table. To demonstrate adjustable, I will edit the table and increase the column width for the catalogue description. And by refreshable, I mean that if my data changes at any time, I can simply press the refresh button and the table will be redrawn with the latest data. The refresh is initiated by a button from the menu. eBase also contains an option for refreshing your tables project-wide, for example after a major revision. For the final part of the demo, I'll show you eBase, our tool for reporting, materials, interconnections, cross-referencing, and many other reports. eBase is also used for project-wide edits, for example, find and replace by part number, project-wide wiring, or even table and wiring diagram refreshing. When doing reporting in eBase, you'll need to select the reports and report types that you require. To generate reports, simply press Compile Reports. You can choose to have the reports stored in your SQL database or stored as DBF files in your file system. eBase provides a button that initiates a refresh of all tables imported to your drawings. eBase also provides a tool to export drawings to simplified DWG, DGN, and if required, PDF files. PDF files can be assembled into a multi-drawing PDF pack. eBase provides access to the Global Editor. The Global Editor can be used to do project-wide edits. The eBase Global Editor allows you to step through the drawing to database transfer, so you can edit or modify your data at any step of this process. Stepping allows you to use Excel and other data tools to modify your data project-wide. Project-wide find and replace is provided within the eBase Global Editor. eBase also provides a button that initiates a refresh of all wiring diagrams within your project. I'll now compile the reports and take a look at some of them. In my project folder, the reports are stored as individual files. eBase provides easy access to this file system folder. Firstly, I will examine the Bill of Materials report file. This report contains every component that I've used in the project, including its tag name, its catalogue number, its manufacturer, and various ratings. Now I'll examine the Bill of Materials summary report file. This report contains a summary of every component type that I've used in the project, including its catalogue number and its manufacturer. Importantly, the quantity of each component type is also provided. Next, I'll examine the cable schedule report. This report contains every cable in the project, the cable name, its catalogue number, and its manufacturer. The termination device of the cable and many routing properties are also provided. eBase can also generate formatted reports. I will examine the core schedule. This report contains every cable core in the project, its cable name, core name, the termination device, and the terminal. This data is used to terminate a cable. These reports are completely customizable, without programming. This formatted report file also contains a cable schedule, which I've described earlier. A formatted materials list is provided in the EDS reports. The data is grouped by panel. This is useful for panel manufacturer. In formatted reports, you can obviously change the fonts, colours, spacings, and the general layout. However, you can also filter and group the data. For example, you could list only the instrument cables in the water treatment area. The next report I will display is the Materials Quantity Summary Report. I examined the unformatted version of this report earlier. A point-to-point panel wire list is provided in the EDS reports. This is useful for panel manufacture. Your wiring team can fabricate from a wire list more easily than searching through your schematics. The final report I will display is the PLC Index report. This report contains all of the I/O details for each card in your PLC. The information includes rack, card and I/O channel, as well as any I/O asset details and cabling information you wish to include. So to recap, I've just shown you the production of 5 or 6 drawings and more than 10 reports with component and data editing and problems resolved, all in under 45 minutes. Some of the features and benefits I have demonstrated are an integrated database giving a higher level of accuracy and less chance of error or rework, a highly productive set of library, drawing and editing tools, automated error checks, navigation, cross-referencing, component naming and table creation, all of which reduce the chance of errors in your project. An automated wiring diagram system which greatly enhances productivity and accuracy when delivering your projects to the wiring and termination team. Catalog specification driven data, again reducing any chance of data errors. An automated report extraction system which elevates your accuracy and improves your productivity. All of those accuracy gains are summarized in this diagram. If you are making less errors, you'll have less rework, your project will take less time and will cost less. Similarly, if your efficiency and productivity are elevated, then your project will be completed faster and cost less. Thank you for watching the demonstration, and please do visit our website and ask us if you wish to get more Electors information or a more detailed demo.